It's a really great pleasure to announce Professor Castro-Caldas, and I want to begin by thanking him for accepting my invitation. And I will try to be very brief because you're not here to hear me, but to hear him. He's a full professor at Católica University and director of the Instituto of Health Sciences at Católica. And he, in the past, was also director of the neurology department at Hospital de Santa Maria. He has been awarded the Bial Prize in Medicine in 2000 and a Distinguished Career Award by the International Neuropsychological Society in 2009. He has authored over 200 papers and books on the brain, and he has been truly, in ways, so many scientific boards and of scientific associations and institutions that I'm not going to attempt to list them here. It would be too long for our precious time. Importantly, I would like to highlight the fact that he's a neurologist by formal education, but I think by vocation he's truly a bridge between many disciplines, including neuroscience, of course, but also psychology and education. And so I think this is an important aspect of his career. Professor Castro-Caldas is known for his breakthrough studies of language in the brain correlates of language, an ontogenetic and lifelong developmental perspective of the brain. That includes how language affects brain architecture, the brain in relation not only to language but to other cognitive functions, and the important and necessary synchrony of educational practices with brain maturation. So you will now hear him speak about this fascinating research on the relationship between brain and our mastery of language.
Good afternoon. Thank you very much for inviting me and for your kind words at this introduction. Being a neurologist, I think that I'm unique in this group, and so I felt that maybe it would be interesting to say a few words about this organ that is not so nice as we see German in pictures in the books. So this is the brain without cosmetics, and that's the way that the brain is seen for thousands of years, and it generates fantasies along the world. So I'll start to mention a few fantasies about the brain in the past, because probably most of the things I'm going to say will be known as fantasies in a few years. So believe me that this is changing every day. Okay, so let's see some fantasies in the past. You can see there was a theory that was very important in the past, is that the liquid that was inside the brain was the more important thing. And this ventricular, this is not working. Okay. This ventricular theory, it's in these 4 drawings over, describes the idea that was the liquid that was inside that was important. This was also used by Descartes in a more sophisticated way, but in a certain way it was also an hydraulic theory about the brain function, and later on the interesting thing of the aspect that of this theory of phrenology, in which we have heads with functions in the air that we can feel with the fingers touching the skull and say, oh, you must be very intelligent because we have here a place, something very important. Well, and many people believed in this, and they went to sessions and they believed it was possible. There is an interpretation also, other interpretations that I think that are interesting. For instance, this interpretation about the Sistine Chapel is that the author, when he painted the creation of man, considered that it was a brain that was designed there to make the creation of man. It was the brain that was doing that. I don't know if Michelangelo was so knew about this. Well, there are, as you saw in the past slides, the drawings of the brain are not so so good, but there are in the past good drawings of the brain without theory or function, but anatomists have done this. Then there is something that is very frequently quoted in lectures and in the literature, is the drawings of Leonardo da Vinci, that is considered a good anatomist. And the drawings of the brain of Leonardo da Vinci are incredible, because he draws the ventricular function. So he was not seeing the brain, he drawing what he thought it was. And the interesting thing, I can't point, but I'll show you. Yeah, it's connected to the ventricles here. This was something that was described by Alcmaeon, a Greek that investigated this. So the eye connected with the ventricles. So he put this. But he was an inventor. So he decided that will be something similar in the hearing. So there is also a canal to the ventricles. So it's amazing. He built the anatomy of the brain, invented the net. Some years later, he did another drawing. He put a substance inside the ventricles, and he had the molding of the ventricles like this. And he designed this as a function of the brain, just the ventricular function, and not the cortical function of the brain. It's interesting that he invented many other things. There are a lot of examples of the anatomy of Leonardo da Vinci with inventions. So he contributed to the development of the body. Well, so these are some of the old fantasies. Then we start studying the brain, and we put some cosmetic in the brain. It's much nicer, that brain there, than the first one. And it was the first thing was to take out the water of the brain and to make it fixed. And then looking at the microscope, and we put colors, and that became much more fancy. So we started with new theories and new fantasies about the brain. And the most important fantasy about the brain that it's already of our time is the idea of left-right connections of the brain, the right and left side of the brain. And we have plenty of drawings in the internet showing this fantastic theory. And then this was due to the appearance of an instrument, fantastic instrument, that make images and considered the Pandora box. It's opening, and it's the final result. We have now something that will allow us to understand what is the intelligence of man and the nature of man. Okay, so with this in mind, we went through some experiments that are important for the future of our talk. And that is some animal work. And this is one of the more interesting aspects of research that was done that influence a lot what is being done in neurosciences of learning and acquisition of functions. There was a poor mouse that was considered to be in a poor environment, and another mouse that is in a rich environment. You can see it's very good to live here. There are companies and other people, and the other one is very sad. And the end was the same. They went to the microscope, both of them, and what happened is that here is the neuron of the poor environment and the neuron of the rich environment. So, fantastic. The rich environment increases the number of dendrites of the neuron. And if you look at the cortex, the characteristics of the cortex is different in several areas of the brain. And so it's very important to stimulate the animal, because the stimulation of the animal increases the quality of the brain. And everyone started thinking, so we have to stimulate our babies. And in generally, but the babies were at home, very quiet in another room. Don't shout, don't make noise because he's sleeping. Now they go to the festivals of music and with some smoke is that not very good for their health, because stimulation is a very important thing. But we have to read this on the reverse. And the reverse is that the poor animal that was in a poor area did not develop what it should develop. So it's the reverse. The reading is the reverse. So you have to, because if I went to nature and pick up a mouse and study the brain of that mouse, it must be much better, much bigger, because the real life is much more important. So the mouse is prepared to have this kind of neurons. The poor one has no opportunity to get that. So the brain, the law that we can take from this is if you don't stimulate the brain, if there is a disuse, you lose the area of the brain. You lose the cells. There is no need, because the brain is very expensive in energy. So it's energy consuming, very expensive. So if you don't use, you lose it. And that's the point. This opened also the idea of plasticity. What is plasticity? Is that relationship of the brain with the environment and how it deals with information and how it evolves. And we can consider that there are curves of development of certain areas of the brain, of cortex, in different ages, and some of them are very important. For instance, the visual, this is the curve of visual cortex. Of course, there is no development when we are inside the uterus, and it very quickly it grows, and then it decreases, and it stabilizes very late, 1 year, at 1 year of age or something. And there is another curve, very important one, this one, that has to do with the frontal lobe. And this is the area, the connection of the inhibitory and excitatory systems of the frontal lobe, and it's a period of health for the parents when there is this convergence of situations. So this is something that is genetic. There is an influence of genetics, and there is an influence of the environment. If we look at development of the brain, there are now maps that allow us to understand that certain areas of the brain, of the cortex, have different densities along the age. This is the curve of age, and this is the several brains, multiple brains in different ages. And I'll show you two of them. In two areas. In this area, the left temporal cortex, the density of the gray matter decreases, and this is related with lexical knowledge, acquiring lexical. What this means is that there is no need in older age to improve our lexical experience unless we try to understand, increase our knowledge about language. But in general, we know everything, so we metabolize what we have. And there is another area, that's the area that for me is more interesting for the moment, is this one that after 70 starts increasing. So I'm very interested in that area to understand what we can do with it. But apparently it's related with philosophical thought and things like that. So I think it's a very good period of life. Okay? So we can say that we have genes controlling this evolution, and the stimulation, I'm sorry it is in Portuguese, but it's a stimulation doing that. And if I asked this from Patricia Kuhl, this slide, and we have here what we have, the biology makes some genetic variation that is responsible for our competencies and on behavior, but the non-genetic variation is very important and influences the organization of the brain, and that's the area we have been working for, understanding how education and social economic stats influence the organization of the brain. So with this in mind, we can look at our subjects. And this is some photos of a good Portuguese photographer and of people in Portugal. And maybe you don't know, but a few years ago, illiteracy was very frequently in Portugal. And still nowadays, in old ages, ladies, at least women, are very frequently are illiterate. And the illiteracy is mainly in the first girl of the family, because when she's reached the age of going to school, she's necessary to take care of the brothers that are small. And when the brothers reach the age of going to school, it's better that they go to school. They have some milk and something at the school. So the older son, or in general the older girl, is illiterate, and the others are literate. So most of my studies were with people in the same cultural environment. I have several sisters here in our studies, older and younger, illiterate and literate. And many times when I present this, they say, "Oh no, they have a low IQ, and they are stupid, they're retarded, mentally retarded." I can show you some of the things produced by illiterate subjects. This is representing of quantities of women that was selling, I don't know exactly what, but selling things. This is the way of making the registration of the selling and of the day. I don't know how it works, but it worked very well. Another example is this notebook with telephone numbers. They can have numbers, this one have numbers, but they have here drawings saying what is a telephone. So there are multiple inventions they do to get the objectives. So let's start by this visual aspect that is very interesting that they are doing. You know, this is, for instance, you see this is the owner of the restaurant. This is the fireman. There's an ambulance here. And this is Candida Coelho, that's a rabbit. Coelho is rabbit. This is almost a rabbit there. So to see what the importance of the visual process in illiterates, and that's a very interesting thing too. The first thing we did was in the comparing literates and illiterates, seeing real objects, photographs, and drawings of objects. And what is interesting is that this was done twice. These are illiterate group. They are very poor naming drawings, photographs, better, and real objects. Better, and this is the literate group comparing, much better, naming the objects. But one of the interesting things in another study that we did with a similar paradigm, we noticed that illiterate groups, and here you have the real object. Here this is the cases they were able to give the name, and this is the time time to have the answer between the presentation of the object and the naming, and they are worst. They are quicker naming the real object, worst in photographs and even worst in drawings. And the reverse with the literate subjects. They are much quicker with the drawing than with the real object, which is very interesting because this is naming the prototype. It's much quicker. The drawing puts outside the operation, and the illiterates, they don't have the concept put in a drawing. So this is a very interesting difference that we have. If we try to ask them to reproduce models, for instance, in this example, reproduce this model from the vendor test. You have many examples of doing that. And, this is segmented in a different way. For all of people that went to school, they immediately segment into two images, and they do it very differently. Each one has a way of doing it. Another aspect now is what was first described by Moraes, that they don't have phonological awareness. So they repeat very poorly non-words. And we ask them to repeat words and pseudo-words, and you see illiterates are very poor repeating pseudo-words comparing to literates. And this is a very easy task to use in a machine for brain images. So this was our first test. So we traveled with our subjects to the Karolinska in Sweden, and we did PET scan using a test of repeating words and pseudo-words. And the interesting thing is that the big difference repeating words and pseudo-words is that this is what happened in the difference between the two groups. This is the activation of the literate subjects repeating pseudo-words. And when illiterates repeated pseudo-words, they have no activation. They were unable to do it. So they were unable to activate the areas of the brain that is adapted to do the function. So they have very poor results in repeating pseudo-words. And when we ask them to repeat words, it's almost similar, with an exception. Literates activated much more this small area here. And at that moment, we are not aware what is that. But then we understood that it's a very important area, even in a monkey, to make the connection between movement and the eye. Information combining parietal information, occipital information, visual and movement. And it is probably the reason why that is activated in literate subject, that is the written word. So it activates the area of the written word. Okay? So we studied a little bit more now the information coming from the area, so from the sensorial aspect. So we made plastic block letters without vision to read. And there is a big difference reading. Those are exilliterates, even exilliterates. That is another group that we use. And they are very different compared to literate subjects reading words written with block letters. They cannot read the letters by touch. So they did not make the connection. This group of exilliterates is a special group of persons that started learning at the age of 50. So they were able to read, but they never went to school before. And we made some studies. I'll show you some of these results. One important thing that we also found in basic anatomy, studying illiterate subjects comparing to literate ones, was in magnetic resonance, we measured the corpus callosum. And we knew that the corpus callosum is sensitive to some influence. For instance, musicians that use both hands for music have a larger corpus callosum. And that's because there is crossing information between the two hemispheres. And we found that was an area of the corpus callosum that connects parietal lobes that is smaller in the illiterate group. And we studied that more deeply. This is the transfer of interparietal is very important. And we try to do an experience. If you use your right hand to write a word, it's very easy to make, with the left hand, make the reverse. With the other hand, you do it in reverse. So we ask, and the idea is that when you are writing, you transmit information to the hand, to a motor system, and you have a memory of writing. It's a motor memory of writing. Many times when we don't know exactly how to spell a word, we write the word to be sure it's well spelled, because we have also a memory, a motor memory of the word. So what we asked was literates to write with the right hand, in the normal writing, and middle writing the left hand. And you see, they do this. If I return this, you can see exactly the same movement. So it's the same program of movement that is crossed to the other side. And it's very easy to do mirror movements with the same program. So we decided to do that with ex-illiterates. And it's very interesting. This is writing, normal writing, the name Maria, and with the other hand. And if you reverse, there is nothing to do with this. He's doing something different. And the most interesting thing is that you can see that the word is reversed, but the letters are not reversed. So they understand exactly what was necessary to do, but they were making a drawing of a visual image, as if I ask them to make the drawing of a tree or a star or something like this. So they don't have the automatic writing, automatic movement of writing. So the transfer between the two hemispheres apparently is not similar. So we went back to our images of PET scan, and we make the comparison of activation to the right side and the left side in homologous areas, in parietal areas of the brain. And it's very interesting. In some areas, we have one group activating more on the left and the other more on the right. And the literates activate more on the right side, the literates activate more on the left side. And other areas, it's the reverse. More on the right in the literates, more on the left in the literates. So this means that the cross-talking between the two hemispheres is clearly different in these two groups. So let's see now something about how the brain adapts to the information and how the brain adapts for reading and writing. For reading, there is an area of the brain that is called the visual word form area here. That is an area that is used for several aspects of the visual, even understanding faces and forms. And when we learn to write and read, we use that area to make that operation. So there is an adaptation. Learning is finding the best resources we have in the brain to adapt to the problem. So the best area of the brain to solve the problem of reading is that one. That is used for other things, but when I start using it to doing a special task, she's specialized in that area. So this area results that there are, from the visual cortex, there are two main pathways, one dorsal and one ventral. This is going to the parietal area where we have movements, and this is going to the temporal area where we have sound. And when we are doing reading, we have to connect this area with the auditory comprehension lexical storing in the temporal lobe, and we have to make the connection of this area to the visual cortex, and the using of this connection makes this area to be smaller, because we also know that when we became practice doing something, we reduce the area of the brain doing this action, because it's always economy. It's always economy everywhere, even in the brain. So this is the way this is formed. And the interesting thing is that when we worked with the ex-illiterate subjects, compared them reading, you can see the visual form area activated in the control, those that went to school when in the proper age, when they were small. And this is the reading effort of those that learning later. So they are using much more brain to do the operation, because it's much more difficult to do the operation, because they don't have the way of going back to the maturity status of the brain to use the old areas. They were dismissed because they are not used. So they are using this, and so we can understand that for them to read a book, it's very difficult, because it's a big effort. Now, if we go to the writing aspect, we have here the fine and movements over there. We have to connect it this also, and then we activate an area for writing. And this is the area that we saw in the PET scan, and what happened with ex-illiterates and controls. Controls activated this same area, and the ex-illiterates activated occipital areas, as we supposed, where is the image, and they copy the image from the visual area, and they are not using that area. So if we don't go to school, you lose a lot. And we also thought that it would be interesting to see if that area of atrophy that we saw in the corpus callosum improved after learning to read. And what happened is that we measured in morphometric studies, and it's still, the corpus callosum did not grow after the 50 years of age. So they cannot make the connection between the two hemispheres. So if you lose in the proper age the opportunity of stimulating the brain, you lose the opportunity to get the function as it should be done. So this is something that, as you see, it's the same area that we found in the corpus callosum of illiterate subjects earlier. There are a few more studies that appear in the literature. Maybe the study of Stanislas Dehaene is interesting, showing the same results mainly in this area, the visual form area, and you have there the activation. Illiterate subjects didn't activate nothing, and literate subjects better activated more. So the area is correlated with the level of knowledge of the operation. So there are other areas involved in reading are connected to this used subjects that were illiterates, ex-illiterates, and literates in two levels of literacy. And there are many differences of using these areas involved in writing. The study of learning later was also studied with magnetoencephalography, because we think there are different studies and different ways of seeing things. And magnetoencephalography is a magnific, a fantastic tool for seeing how the information is processed, time processing of information. And we traveled with these subjects to Madrid, and we did this study in Madrid. And this is controls and late literates, and we can see these are controls, and these are controls. This is the green, and the black is the late literates or ex-illiterates. And you see the time processing. These are the fonts according to time. They appear in the magnetoencephalography, and they get rid of the information much quicker than the exit. The information gets closed, the areas, takes more time to be processed, so you have fonts working there. And this is the number, in general, the number of sources, everything is slower in the group of ex-illiterates. Now going to some areas, this is the right occipital lobe according to time window, and we also see that the controls get rid of information very quickly in the occipital area, so it's very quickly. This is 300 to 400 milliseconds, and the ex-illiterates, they still have information at 600 milliseconds. And this is the left occipital lobe. We have a similar finding. So everything takes longer in the first levels of treatment of information. That's why in all tasks, illiterates are worse than literates when we study them. Well, the last study that I'd like to show you is a more recent information from other studies that came in the literature since the beginning of the century are concerned with the rhythms of the cortical aspects in the areas of language. When we do an EEG, we have different rhythms of the brain. We can have alpha, beta, gamma rhythm of the frequency of the waves in the brain. And this was discovered that they were different in the right and left brain. And Popple connected this with different levels of processing, the level of words, the word intonation and sequencing and syllabic and phonological levels. They have different wavelength. And this was shown in the EEG. And in several papers, this is the same thing, cortical lucidity speech processing. There is apparently a correlation with some of the levels of processing of language. So what we did was very recently to study the language processing by illiterate subjects. And it was very interesting to show that this data suggests that temporal modulation structure of spoken language changes with acquisition of cultural skills, like literacy, that are usually a product of schooling. There is a cultural effect on the temporal modulation structures of spoken language. You can see the differences here. This is illiterates, low literates, and illiterates, and this is the conversational language, and this is rhythmic language, asking them to repeat overlearned sequences like proverbs. There is no difference, but if it's conversational, you see the difference. So producing, we can identify an illiterate subjects by analyzing the oral speech of the illiterates. So this is some of, we are now conducting, pursuing this study, correlating now, trying to correlate the areas of the brain producing language of illiterates to see if there is a correlation between producing and understanding. So I think I show you, I don't know if it was in time, 1 minute. So it was right in time. Thank you very much.